call. I'm here to talk on the use of interdisciplinary approach for teaching school-level astronomy. In the realm of education, what exists is the traditional compartmentalized teaching, where subjects are often isolated from one another. Many education systems have been built around this strategy, which divides the subjects into different silos. Astronomical topics are frequently taught separately from subjects like mathematics, physics, and geography. And as a result of this, students could view astronomy as a standalone science that is not connected to other fields of study. As a result of this compartmentalization, students do not understand the relevance of any topic. This will also impair students' ability to think critically. As we seek to equip students with the skills and knowledge that they need in a multidisciplinary world, a shift towards integrated and interdisciplinary approach is also essential. This shift can elevate students' educational experiences, promote a holistic understanding, and better prepare them to tackle real-world challenges. The Webster's International Dictionary defines the term interdisciplinary as involving the convergence of two or more academic, scientific, or artistic disciplines. That is, this method encourages students to consider issues from multiple perspectives, which will thereby promote critical thinking. This method also recognizes that real-world issues frequently cross numerous disciplines and necessitate a multi-dimensional viewpoint for effective investigation. In this approach, teachers are expected to show students how the linkages and overlaps across various subjects are possible, rather than considering them as distinct entities. This will also encourage the students to think of their studies as connected parts of a larger framework rather than distinct items. This will therefore help them gain a deeper knowledge of the complexity present in every topic by taking into account the numerous disciplinary points of view. Our project centers on the infusion of this interdisciplinary nature into the realm of astronomy education. And to facilitate this integration, the initial step was the selection of a topic that inherently encompasses elements from multiple disciplines. Skimming through the Maharashtra State Board textbooks from grade 5 to 8, both science and geography, led us to the choice of the seasons topic from the grade 7 geography textbook. Beyond its inherent interdisciplinary nature, understanding seasons naturally will lead us to the contemporary and critical issue of climate change. And this will also help us in the involvement of a comprehensive examination of geographical changes, scientific explanations, and mathematical predictions. We used concept mapping, a visual tool, to illustrate complex relationships between the ideas and concepts. It is a useful technique for demonstrating how different elements within an interdisciplinary framework are interconnected. And this will also ease the process of constructing a lesson plan. So this is the lesson plan that we have constructed. The blocks in yellow denote the geographical aspects of understanding seasons, which, as you can see, will ultimately have root in physics or mathematical concepts, that is depicted by blue and pink blocks. With the help of this concept map, we have tried to construct a lesson plan that adheres to the interdisciplinary teaching approach. The root of any astronomical concept lies in basic mathematical ideas. Therefore, before delving into any astronomical topic, it would be good if teachers make students appreciate the importance of mathematical ideas. We would suggest by first revisiting the topic of integers with the help of an activity, and integers was already covered in grade 6 of the Maharashtra State Board. So therefore, students can be made to revisit this topic by engaging them in an activity like maybe ordering images in a number line or solving short problems. Similarly, the concept of 2D and 3D shapes can also be polished by giving students the task to make models of 3D shapes using cardboard. Next, the maths teacher can delve into the geometrical construction of 2D and 3D shapes. And once this idea is made clear to the students, the geography teacher can explain students about the geometry of celestial bodies, emphasizing on the idea of an axis and the tilted axis of the earth. Next, students can be introduced to details of physical concepts like motion, work, distance, displacement, force, etc. And going back to mathematics, the students can be taught about angles and its pairs, and also about the idea of geometry of an ellipse. At this point, the geography teacher can come forward to explain about the revolution of Earth in elliptical orbits. She or he can also take help from online tools like Earth Space Lab for better visualization. Students can then be introduced to the concept of Cartesian and spherical geometry briefly, which will make it easier for them to understand the graticules of the earth in their geography classes. Now that this is done, the physics teacher may move on with the idea of light and the formation of shadows and the effect of light on eclipses, and also explain about the idea of heat and its various effects. At this point, the geography teacher can come forward with the concept of differential heating, which is related with seasons. And she can slowly move on with the core concept of seasons, emphasizing about its interconnectedness. Finally, an interactive discussion session can also be arranged where students will discuss their views and understanding on the topic, and they'll try to relate it with the current happenings. At this point, teachers should also discuss the possible misconceptions that students may have about the topic. So this is an overview of the lesson plan structure. That is, whenever an interconnected topic comes together, teachers have to put the effort to teach it simultaneously in a class. Like we said, simultaneous lessons of geometry of 2D and 3D shapes and the geometry of an elliptical orbit will help students understand the topics much better. So this is how an integrated approach can be structured with the help of art and computation for interactive learning. Having said all this, there are also certain constraints that is associated with the implementation of interdisciplinary approach in a classroom. Schools often operate within rigid structures that separate subjects and grade levels. So interdisciplinary teaching may require reorganizing these structures. The emphasis on standardized tests can also disincentivize educators from exploring innovative teaching approaches, including the interdisciplinary methods. Teachers may also lack the necessary training and comfort to teach across subjects, while standardized assessments are designed for subject-specific content. Also, the collaboration among teachers from different disciplines can be hindered by communication and time barriers. Our work was supported by the National Initiative on Undergraduate Sciences, undertaken by the Homi Bhabha Center for Science Education, TIFR Mumbai, and we also acknowledge the support of the Department of Atomic Energy, Government of India. And these are the references that we used. Thank you.